Okay. Good morning. Can you hear me? Nitum? Can you hear me? Yes, right. Good morning. Okay, good morning. This is the final lesson. Wait. Okay. This is final lesson, 25th lesson. I think you all have this TUTS environment chemistry. Environment chemistry. Get this TUT and everything is given in the TUT. You don't need to fill any space. Everything is given in the TUT. The thing you need to understand this concept. This lesson is very simple because no any calculation, no any difficult things, normal environment related things. You need to understand what are the environment's parts, what are the parts of environment, and what are the cycles in the environment, what are the relationship between these spheres, that mean part of the environment and organism and non-living things, what are the relationships and how these relationships are occurred, and what are the cyclic relationship between these organisms and natural things, natural non-living things, organisms and non-living things. Okay, after that in this lesson we discussed how human activities mean normal industries and other human activities, how effect for the natural environment, how they affect for the natural environment, what are the effect of humans and their effect to natural environment, their effect to natural environment. Okay, in this lesson, actually, some part of this lesson we already discussed. If you got nitrogen cycle, carbon cycle like things, they are very simple that we already discussed, but I hope to give you full idea in this lesson. But in the cell structure lesson, in microorganism part, the nitrogen cycle we already discussed. But in cell structures, I told the full nitrogen cycle we discussed in the environment chemistry of final lesson. In the cell structure lesson, we only did the part of microorganism involvement for the nitrogen cycle. Okay, this is the, if you go to page number 6, you can find the full nitrogen cycle, and there are parts of the nitrogen cycle in the tube. Okay, you all have tube, right? If anyone don't have this, raise hand. This tube. This one. Yes, you all have. Okay. Come lesson. It's very simple. Now any advanced things to discuss. It is very simple, normal. If you read, at least if you read this lesson, you can get the full idea. I have given the full note, therefore I have given full note. You can go through. In this lesson, I hope to explain the background thing. Not to every point I am going to discuss. You have to read and go through this. You can understand basic background things. I'm going to only basic points explain. Okay. Development of technology affects the balance of the environment. Natural cycles in the environment. Okay, if you get environment, what is the meaning of environment? Normally in you grade 6 to 7, 8 from all level time, you define the environment. Okay, if I define environments, what is the environment? What is the environment? What's the environment? Simple thing. What's the environment? How we can define the environment? How we can define environment? Normally in 9 to 8 time also you define the environment, right? Okay, what's the simple meaning of environment? Living and non-living things around us. Normal, this is a simple relationship. But that is not enough for A level, these lessons. You have to explain the environment. The environment means environment. Okay, what's the meaning of environment? The environment is the living and natural things, living and non-living things around us, and they are relationships. They are relationships. They are relationships. That's a simple meaning of environment. Living things and non-living things. Living things and non-living things around us. Okay, around us. And they are relationships around us. Around us. Around us. Living and non-living things with their relationships. These relationships very important. Living things, non-living things relation with living things, and living things relation with non-living things. Okay, that's the meaning of the full idea of the environment. This is the environment. Living and non-living things around us, doing their relationships between them, living and non-living. That relationship can be living and living things, living organism with living organism, and non-living things and non-living things, and living and non-living things. Different relationships. I will explain what are the relationships. They doing relationships. They doing relationship. Okay. The environment is everything around us, all living things. The environment they living, that means non-living, our surround, and they are interact of each other called as the environment. These three words compulsory should have in your definition. What is environment? Living things and they are living environment, that means non-living things, and between them relationships. Living things, living things, and living thing, non-living things relationship that we called as the environment. This is a simple meaning of environment. Environment. Okay, get the keyword. Get the keyword. They are interaction between living things as well as between living things. That means living things like some microorganism reaction with some other microorganism, living and living things and living things. Same as living things and environment. The simple meaning. Okay, have you got the simple meaning? What is the first point? The environment is the living things and non-living things around us, and their relationships. Their relationship we call as environment. If you got these three systems, living things interact with, doing interaction with, interrelationship with other living things and their environment. That means non-living things. Okay. Okay, I will explain. The organism interact with their surrounding and exchange energy and matter. Yes, they normally they are doing interrelations. relationship for get energy and matters. Energy and matters, that's the basic requirement for living organism. For us as example, think we are humans. We are humans. We need oxygen, right? For live, we need oxygen. Where we take oxygen from natural non-living things, from natural environment. We take oxygen. That's a interrelationship. Okay, we doing relationship between natural environment and after our respiration, after our metabolic activities, we release exhaust gas into atmosphere. Okay, that's also we and non-living thing relationship. Okay, therefore the environment is simply the environment is living the collection of living things and non-living things and their relationships. Their relationships normally in organisms get energy and matters from natural environments by these relationships. Are you good? As example, we are living things, we are living organisms. We get energy from sunlight. We get energy from sunlight, and we get matters like carbon, oxygen requirement, water requirement, food requirement from environment, right? From environment. Therefore, we doing relationship between our natural environment, around environment. Okay, that we called as the full meaning of the environment. Understood? Now, can you define the environment? Okay. You all have tute, right? Without tute, difficult to do this lesson because no any calculation or no any advanced things in this lesson. Again, if you anyone don't have these tutes, please raise hand. This tute. This is environmental chemistry. You all have, right? Okay, get the tute. Okay, very simple thing now we discussed. What's the meaning of environment? What's the meaning of environment? Around us living things and non-living things and their relationships. Living things always doing relationship between non-living things for get energy and matters. Okay, that's the simple summary of the first paragraph. Okay, for easy study, for easy learning, the environment we can divide into 4 parts. 4 parts. They are hydrosphere. Hydrosphere means water available all environments. Water environments, water part of the earth we call as hydrosphere. Hydrosphere. The air available, all parts we call as atmosphere. The earth, soil, rock, mineral available, all parts we called as lithosphere. Including this hydrosphere, atmosphere, and hydrosphere, atmosphere, and lithosphere, organisms live in maximum range. Organisms live in maximum range that we call as biosphere. Understand? Hydrosphere, water. Atmosphere, air available part. Lithosphere, soil, mineral, rocks available part. Hydrosphere, atmosphere, lithosphere, organisms, whatever living organism, animal, plant, or microorganism, whatever living organism available range that we call as biosphere. The environment where all living things belongs, plants and animals and microorganism also. One word is missing, microorganism. Okay, that is the biosphere, simple meaning of biosphere. This is the biosphere. This is the air available normal surrounding we call as atmosphere. This is a hydrosphere, water. This is the lithosphere, soil. These all parts, organism available part, if we separate, organism available part, if we separate, that we call as biosphere. That we call as biosphere. Biosphere. The above spheres are not separate from each other. Yes, these if I separate biosphere, atmosphere, um, lithosphere, like if I separate it, they are not separate parts of the earth. They are for easy study only. We separating them. If not, they are same parts and they are doing dynamic relationship between for exchange matters and energy between them. They're doing relationship between them. Otherwise, the natural circles we cannot maintain without this relationship. Okay, therefore these relationships are very important. If I that you need to remember. If I separate like this, if I separate the Earth into a hydrosphere, atmosphere, lithosphere, and biosphere, they are not separate parts. They are uh, different parts of the Earth doing doing relationship between each other. Doing relationship between each other, not full separate parts of the Earth. Okay, come to page number 2. Okay, as I explained, a few examples given here. Water vapor moves from hydrosphere to atmosphere. You know, evaporation. In evaporation, what happened? The water vapor from water surfaces mean hydrosphere, it's going up. Then it is atmosphere. Atmosphere, it is a relationship, and also organism like us for get oxygen from the atmosphere and we get food from biosphere because plants, biosphere, and we get minerals from the lithosphere like sodium hydroxide minerals, we and a lot of minerals coming with drinking water. Then we got water from hydrosphere. We get water from hydrosphere and water from the hydrosphere. Then finally carbon dioxide released to the after respiration, carbon dioxide exposed, carbon dioxide released to the atmosphere. Then you can see as a we are biosphere, we are organisms, we are biosphere. As biosphere doing relationship between each and every part of the earth. Okay, therefore they are not separate parts. They are only separating for easy study. They are parts doing relationship between each other. This relationship very important for the keep balance of the earth and our environment. Up to now, okay? Any doubt? This lesson very simple. If you read the tune, you can get full idea. Understood up now? Get the full idea within the class. Again, don't keep anything to do later because you don't have time. You have a few days. Okay, only 3 point I told. What is the definition of the environment? Living things and non-living things around us, and living and non-living things relationship we called as an environment. Environment for easy study we can divide into 4 parts: atmosphere, hydrosphere, lithosphere, and biosphere. They are not separate parts. They are doing relationships between them. These relationships very important for keep this balance in the environment for biodiversity. Understood? Please send me quickly. Only 3 point. Quickly send me. Okay, then natural cycles. Okay, natural cycles are flowchart networks. Here, flowchart networks. Flowchart networks, the relationship between these elements, and that means energy and matter transmission between this atmosphere. So between these parts of the, between these parts, the cycles mean energy and matter exchanging actually throughout the environment, energy and matter exchanging, that we call as, that flow charts we call as natural cycles. Natural cycles can be described as a flow chart or network that represent the exchange of elements between different spheres. Yes, exchange of elements between different spheres, sometimes lithosphere to atmosphere, and again atmosphere compound come to lithosphere and hydrosphere, and it's go through the biosphere. Like these cycles that we call as natural cycles. Natural cycles, cycling the matters between spheres. Remember, cycling the matters between spheres. Matters and energy also sometimes energy also sometimes work as a cycle. Work as a cycle. Okay, this is the cyclic of matters. You can see it's this is a hydro cycle, namely rain, and that we call as water cycle, right? Water cycle. See, water cycle, it is evaporation, evaporation and transpiration, evapotranspiration, evapotranspiration. Then it is produced cloud by condensation, that you already know. Evapotranspiration, then condensation, they produce clouds. Produce cloud. These clouds are flowing through from the upper atmosphere. Then it is precipitation. Precipitation mean rain. Precipitation mean rain. Then again, this water go inside to the soil and go along the soil, along the ground and inside the ground by percolation, that we call as percolation. That is hydrocycle, water cycle. Percolation, percolation and runoff, that we call as runoff. I think you already know. Runoff mean go along the soil. Again, land decay, that we call as runoff. Go inside to soil, that we call as percolation. Percolation, then it is come to again water bodies and that absorbed by water, then again evapotranspiration, evapotranspiration, transpiration and evaporation, then again cloud formation, again rain, again it is a cycle. It's a cycle. It's a cycle. Okay, that carbon cycle, same. Carbon cycle, you can see it is a cycle. One by one we can discuss. Nitrogen cycle, same. Nitrogen cycle, part of nitrogen cycle that we have discussed in the cell structure lesson, only for microorganism involvement. Today, I will explain the full nitrogen cycle for better understand. Among them, the carbon cycle, nitrogen cycle, carbon cycle, nitrogen cycle, ozone oxygen cycle can be defined the cycles most effective for technology. For technological improvements and approach, the most effective, most important cycles are carbon cycle, nitrogen cycle, and ozone oxygen cycle. Okay, now we're going to discuss one by one the cycles. Okay, before that, in this next part, we're not going to discuss this water cycle. This water cycle also important for your for technology, because water is a main resource for living organism as well as industries. The water cycle also important. Remember, this is that we call as evaporation from water bodies, water vapor evaporation from water bodies. Then from plants, that we call as transpiration. I think you can familiar these words. Remember these words: evaporation, evaporation. Sorry, this is evaporation. It is given in the tube, right? This is evaporation. Evaporation. This is transpiration. The evapotranspiration means the both evaporation and transpiration both, that we call as evapotranspiration. 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 Then in the upper atmosphere, it is condensation. Then produce clouds. These clouds form floating in the upper atmosphere. When it is again melting, it is precipitate as a rain. Precipitate as a rain. Precipitate as a rain. Then finally, that we called as runoff. Runoff go along the land, then it's go inside to land, that we called as percolation. 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 Then again collect to water bodies and absorbed by plants. Then again evapotranspiration. Then again cloud formation, and it is a hydrocycle or water cycle. Hydrocycle or water cycle. Understood hydrocycle? Mitu? Okay, carbon cycle, nitrogen cycle, ozone, oxygen. Ozone, oxygen mean mainly oxygen cycle. Oxygen cycle mainly important for your for our technological effects and technological usages. Okay, come to carbon cycle. In the carbon cycle, different chemicals form in which carbon elements exist in different spheres. Yes. Okay, I'm not going to explain this point by point. I only explained the full carbon cycle. Then you can go through this note and you can get the full idea. Okay, come. And I have given some space here. I have given space. After you understand, you can draw your own carbon cycle and keep remember. Okay, in the page number 4, I have given space for you. After you understand, you can draw your own carbon cycle here. Then you can get remember this carbon cycle. Each points it is important for your structured paper and essay part chemistry question. Okay, this is a final. This is a carbon cycle. Okay, this is a carbon cycle. You can see. Okay. Okay, this is the carbon cycle. Normally, main carbon carbon source available in main carbon available in atmosphere as carbon dioxide. Main carbon type is carbon dioxide. Then this carbon dioxide, they are the for photosynthesis process. For photosynthesis process of the plant in biosphere, the carbon dioxide is a main raw material, right? Carbon dioxide is the main raw material for photosynthesis process. Biomass, that means plants absorb this carbon dioxide. After that, in the respiration of plants, you already know, plants in daytime doing their photosynthesis, then absorb carbon dioxide and release oxygen. But in the night time, plants like us, plants doing respiration. Plants respirate. In the plant respiration process, what they doing? They like us. They absorb oxygen and release carbon dioxide. In the respiration of plants and animal, it is release carbon dioxide into atmosphere. Understand? For photosynthesis, carbon dioxide absorbed by plants then in the respiration of plants and animal both, this carbon dioxide released again to the environment. Okay. Now, additionally, deforestation, that means something decomposition like organic matter decomposition and combustion, both decomposition and combustion, carbon dioxide from biomass, carbon dioxide released to the atmosphere. Okay, after that, some aquatic biomass, also aquatic plants, algae and aquatic plants in water available plants also absorb carbon dioxide for their photosynthesis. Same in their respiration and decomposition, again release carbon dioxide to the atmosphere. Again release carbon dioxide atmosphere. Okay, this aquatic organism release carbon dioxide, and the normal environment dissolving carbon dioxide, it is dissolved in sea water and normal water, hydrosphere, dissolved in hydrosphere, and they are decomposed as carbonate, deposit as like in the bottom of hydrosphere, that we call as carbonate, marine deposit mean mohude deposit වෙන, and they are the limestone and dolomite. They are the parts of after when increase the deposition, they are made as a thick layers, and finally okay, that is diffusion mean that's directly atmosphere carbon dioxide dissolved in hydrosphere, and that again released to the environment, that is dissolved in water bodies and again released to environment. This is a cycle. Okay, the other thing, this biosphere, I told more than millions of years they take, then produce fossil fuels. The fossil fuel contain carbon. The fossil fuel, this limestone, they are the fossil fuel, and coal, oil like crude oil, they are the fossil fuels. Then this fossil fuel take out from industries, different industries. Then these different industries, fossil fuel combustion, and vehicles also fossil fuel combustion. Then again carbon dioxide released to the atmosphere. Okay, now you can understand some parts of some process, photosynthesis and biomass deposition and carbonic deposition. They produce carbon in the lithosphere and hydrosphere, and some decomposition, respiration, fossil fuel burning, and diffusion, they release carbon dioxide into atmosphere. Then you can see it is a cycle. It is the carbon in the environment working as a cycle. Understood? Any part couldn't you understood? Please let me know. This is very simple. In photosynthesis of biomass and aquatic biomass, it is absorb carbon dioxide. Then their respiration and decomposition release carbon dioxide. This is direct dissolving in seawater. It is dissolving and again released to environment. Then some part of carbon dioxide dissolved in this seawater and hydrosphere, it is deposit as deposition. Then it is produced this type layers. Then this, when millions of years take this biomass convert into fossil fuels, then this fossil fuel convert again into carbon dioxide by combustion, fossil fuel combustion. Okay, now this is a simple cycle. Okay, I have given space. You can draw your own carbon cycle and name these all parts for easy understand. Are you good? Understood? Adisha, please remember within the class, don't take time again. It is very simple. Atmospheric carbon dioxide absorbed by biomass in the earth and hydrosphere for photosynthesis. Then their respiration and decomposition again release carbon dioxide into atmosphere. Carbon dioxide available in atmosphere directly dissolved in water. Then some part of carbon dioxide again transfer to atmosphere. Then part of carbon dioxide deposit as deposition. Then it is produced this type thick layers. Then biosphere biomass again deposit millions of years, then produce fossil fuel burning, again carbon dioxide released to atmosphere. Okay, that is simple. Any doubt? Now keep remember within this time, again don't take time. This type very simple lessons, don't take time. Simple carbon cycle. Carbon is go through the environment as a cycle. Then remember this all words, everything within the class. Okay, can you draw your own carbon cycle with your understand in the previous picture? Okay, now I can give you 3 minutes. Quickly draw this. Quickly draw. Starting from carbon dioxide, I am not going to draw. You have to draw in your own bar. Starting from carbon dioxide, then draw a small carbon cycle. Quickly draw. Mention all process in the carbon cycle: respiration, decomposition, photosynthesis, diffusion, uh, deposition, and biofuel uh, burning, and fossil fuel burning, everything. Complete. Complete. Quickly draw. No need beautiful pictures. Only need mention this process. Okay. Please complete the table. Nitrogen cycle, very important. You can read in previous page note. You can read and prepare your short notes if you want. Don't need actually. It's simple. Okay, you can understand. Okay. Okay, come to nitrogen cycle. Nitrogen cycle is the most important cycle in the technology. This is very important because 78%, more than 78% nitrogen percentage in our atmosphere. Carbon dioxide only 0.2. Carbon dioxide only 0.2. Nitrogen, it is more than 78. Therefore, it is very helpful. It is very helpful and important industries. But the problem is this nitrogen gas very stable, not like carbon dioxide. They are very stable as nitrogen gas, very limited to use for industries. Okay, but when compared to carbon cycle, nitrogen in biosphere, lithosphere, and hydrosphere is very limited. They are very limited. The reason is the main reason is that nitrogen gas is the atmosphere very stable. That is very stable and very low reactive gas. Nitrogen low reactive gas. Normally, if you got plants, plants most required nutrition type is nitrogen. Most required, most demanding nutrition type of nitrogen. But the problem, if it is 78%, more than 78%, 78.1, right? So more than 78% nitrogen in our atmosphere, plants cannot absorb nitrogen as a nitrogen gas. That's the main problem. Plants cannot absorb nitrogen as a nitrogen gas. Then this nitrogen cycle important for keep balance in the environment. Keep balance in the environment. Okay, nitrogen cycle, part of nitrogen cycle, microorganism involvement that we discussed in the cell structure. This is a full nitrogen cycle. Full nitrogen cycle. Full nitrogen cycle. Okay, nitrogen cycle, we have to go through that. Okay. Okay, I have given here in atmosphere nitrogen gas, NO2 gas, nitrous oxide, N2O mean nitrous oxide, NO mean nitrogen monoxide, NH3 mean ammonia. If you don't know, you can note down. Nitrogen gas, N2 mean nitrogen gas, NO2 mean nitrogen dioxide, carbon dioxide CO2, NO2 nitrogen dioxide, N2O mean nitrous oxide. Nitrous oxide, NO carbon monoxide. Remember, CO mean carbon monoxide, NO nitrogen monoxide. Nitrogen monoxide. NH3 ammonia. NH3 ammonia. There is another one. NH4. NH4 means ammonium. Ammonium. This is ammonia. Okay, in biosphere, in the proteins, in proteins in our body, it is contain nitrogen and DNA and RNA in our nucleic acid. In hydrosphere, ammonium. Sorry. It is only atmosphere. Don't have atmosphere ammonium. Ammonium is a mineral. Sorry. Ammonium is a mineral. This is ammonium. It is available in lithosphere. Sorry, it should come to lithosphere. Okay. Lithosphere. NO3 mean nitrate. NO3 minus. Please correct this. NO3 minus, that we call as nitrate. Ammonium. This is ammonia gas. It is available in atmosphere. Okay, clearly understand these things. In every exam, these questions come. Ammonia gas, NH3. This is ammonium mineral. Ammonium. Ammonium plus is iron. Ammonium iron. NH3 minus nitrate iron. If you don't know, please note down. NO2 minus nitrite iron. Nitrite iron. Nitrite iron. Okay, this is lithosphere. Lithosphere. Okay. Lithosphere as nitrogen containing minerals. Nitrogen containing minerals. Lithosphere also these minerals. Ammonium, nitrite minerals containing in lithosphere. Normally lithosphere available dissolved in water. Dissolved in water. Soil එකේ තියෙන්නේ water එකේ dissolved වෙලා. Okay. Okay. Nitrification. Nitrification, you already know the nitrogen cycle. There are two main components, nitrification and denitrification. Nitrification means simple. Nitrification, you already know, nitrification means nitrogen gas converting to NO3 ions. That's the simple meaning of nitrification. Nitrification means nitrogen gas converting to nitrate. Nitrogen gas converting to nitrate. Normally the problem is if it is 78% of nitrogen in atmosphere, plant cannot absorb this at least 1% nitrogen from atmosphere. 0.1 at least cannot absorb. Therefore, nitrogen need to convert into nitrate ions. These nitrate ions can available for plants. Nitrogen ions, nitrate ions, plants can absorb and doing their requirement, fulfill their requirement. Okay. The nitrification means mainly nitrogen atmosphere nitrogen converting to nitrate ions. Nitrate ions are the plants available nitrogen type. Plants available nitrogen type. Then denitrification, the second one. Denitrification means denitrification, go to second page number 7. The denitrification means simple. Nitrate ions converting to nitrogen. See, very simple. Nitrogen ions, nitrate ion, NO3 ions converting to nitrogen gas. Nitrogen gas. Simple. Nitrogen gas. Nitrogen gas. Denitrification means opposite. Nitrification means nitrogen gas converting to nitrate ions. Denitrification means nitrate ions converting to nitrogen. Okay, these chemicals names you have to remember. Chemicals names, these names very important. If you don't know these names, please I will explain again. Nitrogen gas, NO2 means nitrogen dioxide, N2O means nitrous oxide, NO means nitrogen monoxide, NH3 means ammonia gas, NH4 means ammonium ions, NO3 minus mean nitrate ions, NO2 minus nitrite ions, nitrites ions, nitrite ions. Okay, this nitrification, why this nitrification is required? As I told, if it is 78% nitrogen in atmosphere, plants cannot absorb this nitrogen. Plants cannot absorb this nitrogen. Therefore, nitrogen gas need to convert into nitrate ions for absorb for plants. For absorb for plants. Okay. Nitrogen, which is main elements needed to living things, it is not available most living things from the atmosphere. Even though it exists in large quantities in atmosphere, 78%. Therefore, atmospheric nitrogen should be converted into useful nitrogen. Useful nitrogen means NO3. NO3 minus. This process is known as atmospheric nitrogen fixation. Atmospheric nitrogen fixation. Actually, this process is nitrification main process. Two main processes in nitrification. First, nitrogen gas, whatever method, convert into ammonium minerals. Ammonium minerals. Nitrogen gas, whatever method, very understand careful. Nitrogen gas, whatever method, I will explain what are the method. Nitrogen gas, ammonium, sorry, NH4, right? NH4 minerals. NH4, ammonium minerals. Ammonium ions. Ammonium ions plus ammonium ions. Then after that, these ammonium ions by microorganism activation on this ammonium ion that we convert into nitrite ions, N2O ions. Nitrite ions. Yes, NO2 ions. Then after that, again microorganism activation, it is converted to NO3 ions, NO3 minus. That is the plant available microorganism type. This nitrogen gas convert into ammonium mineral, ammonium ions that we called as the atmospheric fixation. Atmospheric fixation. Atmospheric nitrogen fixation. This ammonia convert into nitrite, nitrite convert into nitrate. It is microorganism process. I got. Do I need to explain again? This is very important. Always asking. That's why I can again explain this part. You know, if you go through past papers, lot of nitrogen cycle questions, carbon cycle, oxygen cycle, no questions you can find. Understood? But they are also important. You have to cover. Understood? Please in. Or do I need to explain again? Mithum, I got. Which part am I? Nitrification, this part. Okay, nitrification mainly 3 steps actually. First one, nitrogen gas. Normally nitrification, that's the nitrification full target is nitrogen gas finally converted into nitrate ions. Okay, it is not a one step. This is not a one step. It is mainly 3 steps. First of all, this nitrogen gas convert into ammonium ions, ammonium plus, NH4 plus, NH4 plus. Then these ammonium ions, NH4 plus convert into nitrite ions, NO2 minus nitrite ions. This is a microbial process that you already know in the cell structure. Nitrite ions then finally convert into nitrate ions. This is a plant available, plant required ion. This is our target of nitrification. Then it is also microbial process. But before produce this nitrate, first step is nitrogen gas convert into whatever method ammonium minerals, ammonium ions. That process, the first step we called as atmospheric nitrogen fixation. Atmospheric nitrogen fixation or nitrogen fixation, we called it is as nitrogen fixation main. Nitrogen fixation. Okay, in nitrogen fixation part, what is the target? Nitrogen gas convert into ammonium ion. That's the target. Then when it is ammonium ion produced, remain part is doing by bacteria. In soil, when produce ammonium ions, other part is doing by bacteria, but this ammonium ion production is important. Ammonium ion production in the important. Normally, in our fertilizer applications, we can apply we can directly apply urea. Urea contain chemically nitrate, chemical nitrate ions. But the good practice, we can introduce ammonia for soil, ammonium ion for soil. When we apply ammonium ion, what they doing? Soil available microorganism doing remain process. Understood? Okay. They are the atmospheric nitrogen fixation methods. Atmospheric nitrogen fixation method. Atmospheric nitrogen fixation means nitrogen gas convert into ammonium ions. These methods mainly 3 types. See, nitrogen fixation method, biological fixation, atmospheric fixation, and industrial fixation. Actually, it is nitrogen fixation. Nitrogen fixation means nitrogen gas converted into ammonium ions. This nitrogen fixation mainly 3 types: biological nitrogen fixation, atmospheric nitrogen fixation, and industrial nitrogen fixation. Biological nitrogen fixation, atmospheric nitrogen fixation, industrial atmospheric fixation. Okay, come to biological atmospheric fixation, you already know. Biological by microorganism. Biological nitrogen fixation is doing by certain microorganism, bacteria and cyanobacteria. Here, atmospheric nitrogen is converted into nitrogen containing organic compounds. Nitrogen containing organic compound by the microorganism. After they die, they digest and release ammonium ions. Ammonium ion, very important. Ammonium ions into the soil. Ammonium ions into soil. Some of these bacteria, like cyanobacteria, that you already know. Some of these bacteria, like cyanobacteria, freely available in the soil and doing their nitrogen fixation process. Some type of microorganism live as symbiotic. Some bacteria freely available, some type of bacteria symbiotic relationship with other organism, then they are doing their job, this nitrogen fixation process. Okay, they are the freely living nitrogen fixation microorganism: Acetobacter, Anabaena, Clostridium bacteria. Remember, when you write microorganism name, you have to follow the rules. First letter capital and underlining. It is very important. Acetobacter, Anopina, Clostridium, they are the bacteria doing freely living in the atmosphere, not in the soil, and doing their job, freely living and doing nitrogen fixation process. The second one, symbiotic relationship that we know, that you already know, leguminous plants, root nodules. In the root nodules in the leguminous plants, leguminous mean what soya bean like plants, they live symbiotically. Rhizobium symbiotically live in nodules of leguminous plants. Then they are doing nitrogen fixation process. Okay, that's a biological fixation. What is a biological fixation? Freely and symbiotically available microorganism convert nitrogen into NH4. That's the nitrogen fixation. NH4 plus. This is simple nitrogen fixation. I got biological nitrogen fixation. Freely or symbiotic available microorganism in the soil doing their job. What they doing? Nitrogen gas convert into ammonium ions. Understood? Adisha? Okay, the thing you have only 1 month. Within next week, I hope to complete everything. Within next week, my final. We have another week in this month, right? Next, I think this next Wednesday is the final day of this week, this month. Then I hope to complete everything for you. This lesson and electricity. We have small part. And next month we have special seminar for electricity. Then I will again refresh everything. Kirchhoff laws and every calculation we can again discuss one more time within short time. And your works will be finished within this week. Every works in your syllabus, and you have only ICT practicals. ICT practicals, let's try to discuss tomorrow. Tomorrow let's start, then next week we can complete. In within next week, everything, your all works will be completed, then you have to finalize your works for the exam. You have 1 month. After completing everything, you have 1 month. You have enough time. You work. Okay. What is that? First one is biological nitrogen fixation. Biological nitrogen fixation means freely available or symbiotic microorganism convert nitrogen gas into ammonium ions. Ammonium ion. Okay, this is the atmospheric nitrogen fixation. Atmospheric nitrogen fixation means in the lightning, during lightning, ඒ කියන්නේ මේ අකුණු ගහන වෙලාවට විදුලි කොටන වෙලාව, large amount of energy is released during lightning, and this energy break down nitrogen into atmospheric nitrogen come to soil as ammonium minerals. It is very rare process, but it is also atmospheric nitrogen fixation. Those oxides can dissolve in rainwater, and yes, this oxide, the nitrogen oxide is produced NO. Then this NO dissolved in rainwater. Then it is come to soil and convert into ammonia. Then N2 in lightning, that's the atmosphere, lightning. අකුණු ගහන වෙලාවට nitrogen gas convert into NO, nitrogen oxide due to this huge uh, energy, it is converted to NO, then it is NO dissolved in water, it is come to soil as in NH4 plus ions, that we called as biological nitrogen fixation. Biological nitrogen fixation. Biological nitrogen fixation. Biological nitrogen fixation. Final one, industrial nitrogen fixation means artificially in industries. Artificially in industries, nitrogen gas converted into ammonia fertilizer. Ammonia fertilizer, NH4 fertilizer, that we called as ammonia is used to produce nitrogen fertilizer. See, nitrogen fertilizer, that means ammonium gas, nitrogen and ammonium gas, NH3 gas converted into ammonia fertilizer, that we call as industrial nitrogen fixation. When this fertilizer add into our lands, our farm lands, growing lands, then it is nitrogen fixation. It is industrial nitrogen fixation. Industrial, within industries, within production compound. Artificially nitrogen fixation, that is human involving process. Ammonium ions are added to soil when nitrogenous fertilizer are applied to soil. Understood all nitrogen fixation method? What's the nitrogen fixation? Nitrogen gas convert into ammonia ions. Ammonium ion, NH4 plus ions. Then it is three main method. Atmospheric nitrogen fixation by lightning. Remember, industrial nitrogen fixation in industries artificially for fertilizer production. Biological nitrogen fixation by microorganism, pre or symbiotic microorganism. Clear? Okay. From this point, nitrogen fixation is complete. Nitrogen fixation complete. It don't have separated. You can. This is a nitrogen fixation. After that, it is nitrification given. Okay, you can mark this. From this point, nitrogen fixation is completed. You can mark on the tube. Okay. Nitrogen fixation. After this nitrogen fixation, what is produced? I told from different methods, ammonium ions come into soil. Then biological fixation, atmospheric fixation, industrial fixation coming ammonium ion to soil. Then these ammonium ions, see these ammonium ions by nitrosomonas, you have to remember this microorganism name. By nitrosomonas convert into NO2 minus, that means nitrite. Remember these names, nitrite ions. Then by nitrobacter, nitrite ions convert into nitrate ions. This is a plant available nitrate ions. Nitrate ions. This is a plant available nitrogen type. It is doing this ammonium ion convert into nitrite, nitrite convert into nitrate, doing by microorganism. Ammonium convert into nitrite, remember nitrosomonas. Nitrite convert into nitrate, remember nitrobacter. Understood? This is the full nitrogen cycle. This is a full nitrogen cycle. Please send me I got. Shehan? Madishan? I clear? Ashit? Remember, like this story, please remember. Don't take too much time for this simple lessons. This is very simple lesson. No any calculation, no any complex equations. Simple nitrification. Okay, these nitrate ions absorbed by plant roots and eventually becomes plant proteins. Yes, this plant protein, these nitrate ions absorbed by plant roots then produce plant proteins. Plant proteins. For plant protein, amino acids. It is very important nitrogen. For this nitrogen used for plant proteins. Then when this plant material, plant and then we eat plant material, then the plant protein come to our body. Then when these plant and animal materials, plants and animal materials, living things, what happened when again released to the, when dead and decompose, again release this nitrogen into soil as a ammonium. That's called as ammonification. This process is called as ammonification. That's the final process you need to remember. This nitrate is produced, okay, by this above process. Nitrate is produced. The nitrate absorbed by plants. Then this it is produced plant protein. Then this plant food utilized by us as an organism, as animals. Then animals and plant available protein come to again, when they are dead, again come to soil and decompose in release ammonium into soil again. Then this ammonium, the production process that we call as ammonification. That's the ammonification. Protein, animal and plant protein convert into ammonium again, that we call as ammonification. Ammonification, remember this name, ammonification. Okay, the ammonification produce ammonium, again convert into nitrate by this above microorganism, Nitrosomonas and Nitrobacter. Okay, now you can see this is a full cycle. Okay, this is denitrification. You already know. Remember, this nitrification always doing in aerobic conditions. Aerobic condition, oxygen is compulsory for this microorganism and symbiotic and freely available microorganism and this Nitrosomonas Nitrobacter, they are aerobic microorganisms. If they don't have oxygen, nitrification bacteria will be dead, destroyed. Then start to pseudomonas like anaerobic bacteria. This anaerobic bacteria, what they do in nitrate ions directly convert into nitrogen gas. That we call as directly nitrate ions in the soil directly convert into nitrogen gas and release to environment, release to atmosphere. In some cases, bacteria activity cause usual nitrogen or nitrate ions present in the soil leave from the soil. The process called denitrification. Here, it is not the nitrification, it is denitrification. Mistake. The process called denitrification. Here, nitrate ions in the soil are converted into atmospheric nitrogen gas. Remember, it is anaerobic microorganism, Pseudomonas. Pseudomonas is the main bacteria important for this. Pseudomonas. Okay, understood nitrogen cycle. The nitrogen cycle is complete. Now you have a task. Draw a nitrogen cycle again. Okay, this is a nitrogen cycle. That's atmospheric nitrogen. Atmospheric nitrogen. Atmospheric nitrogen. Then this atmospheric nitrogen, this is the full process. First, nitrogen fixing bacteria. See, nitrogen fixing bacteria absorb this nitrogen, convert into ammonia. Finally, it's converted into ammonium. See, this nitrifying bacteria then again convert into nitrate. This nitrate absorbed by plants, then again its dead particle come to soil. Again, that is called as ammonification. Then denitrification bacteria, what they doing again convert ammonium into nitrogen. Okay, you can prepare a nitrogen cycle. If you got the full understand, you can draw your nitrogen cycle on this given space and complete the tip. Okay, any doubt in nitrogen cycle? Quickly ask. Any unclear point? Amavi, I got it. Okay, you can draw your own nitrogen cycle in the given space. Okay, come to oxygen cycle. Final cycle. Okay, give me a second. Okay, final cycle, the oxygen cycle. The atmosphere contains about approximately 21% of oxygen that you already know from the total volume. But unlike oxygen, is very reactive gas. Because of this, unlike nitrogen, it is not like nitrogen. I told nitrogen is very unstable and it is very stable and non-reactive gas. But the oxygen is not like nitrogen, it is very reactive gas. Because of this atmosphere, oxygen directly involved for many reactions that you already know. It is reactive gas, very reactive gas. Also, because of this high reactivity, oxygen is tightly bound to nitrogen and carbon cycles. Okay, it is involving for NO2, NO3. Always oxygen is required for carbon cycle. CO2, oxygen is compulsory. For nitrogen and carbon cycle, that is important. Oxygen is also associated with the process of biometabolism that you already know. Nitin, what you asking? I thought it is a hydrocycle question. No, you're not reading. Why? Quickly, why? Here is heavy rain. Don't think. Oxygen is also as a yes that we discussed many metabolism and combustion. Just metabolism that our main requirement is oxygen for respiration. It is important for our metabolic activities and combustion also main gas oxygen that you already know. That means burn. Oxygen is bound in all biomolecules and the main component of water in the hydrosphere. Water means H2O, right? H2O, the main molecule is H2O, main molecule, water. With two hydrogen molecules, the oxygen is the main molecule. And okay, it is given basic things about oxygen. Similarly, in soil minerals and rocks, oxygen is present as main component elements. Yes, minerals and rocks. Minerals and rocks. Oxygen is applied to the atmosphere mainly through photosynthesis. Yes, that's the main process. Provide oxygen to atmosphere by photosynthesis. Lithosphere and hydrosphere plant by bio biological plants photosynthesis, it is produce oxygen to atmosphere. Plants and animals need oxygen for their respiration. This is actually for photosynthesis, carbon dioxide convert into oxygen. That oxygen absorbed by plant and animal for respiration. This oxygen convert into carbon dioxide by respiration. That's the process. That's a cycle actually. Okay, it is given the oxygen cycle. It is given oxygen cycle. This is oxygen gas. This is oxygen gas. This is oxygen gas in atmosphere. Photosynthesis, sorry, photolysis. That means it is a, I will explain what's the meaning of photolysis. Okay, in the next part. In photosynthesis, it is produced oxygen from plants to atmosphere. Plant and animal respiration, it is absorbed by plants. Industrial combustion, it is absorb oxygen. For combustion, they release carbon dioxide. This release carbon dioxide by animal respiration and industrial combustion released by plants for photosynthesis, then again convert into oxygen. That's a cycle. Okay, very simple. Animal respiration also same, absorbed by plants and this respiration. Animal respiration absorb oxygen and release carbon dioxide. That's absorbed by plants. Then you can understand the function of the plants. It is a main oxygen supply. Main oxygen supply. Everywhere collecting carbon dioxide converted to oxygen by plants. Then it is fossil fuel decomposition required oxygen. This oxygen again convert into carbon dioxide in burning. It is reduced to atmosphere. Then this carbon dioxide contain oxygen, two oxygen molecules. Carbon dioxide also oxygen source. Okay, that's the main thing you need to understand. Again, you can draw this in the given space. In the given space, you can draw this again. Your atmospheric oxygen, then respiration, photosynthesis. You can again go through and draw a oxygen cycle. Okay, it is given Singharatam. It should be UV rays. UV rays. So did we discuss page number 3? What's the page number 3? Page number 3, carbon cycle. Right? Carbon cycle you have to refer. Page number 3 only mention carbon available forms in atmosphere, lithosphere, hydrosphere that you can go through. I explained only carbon cycle because carbon cycle is easy. Okay, Shyam? Okay. This is the oxygen-ozone relationships. Oxygen-ozone relationship. The oxygen-ozone relationship means in upper atmosphere, you already know there is a layer that we call as ozone layer. Ozone layer. This ozone layer made up with this oxygen. I'll let you know. I will explain the atomic oxygen. Normally, first of all, this carbon dioxide, by this UV radiation, UV rays, it is converted to atomic oxygen. Oxygen plus oxygen. O2 converted into O. O mean atomic oxygen molecule. Then this oxygen molecule convert into oxygen again. Sorry, oxygen molecule converted to oxygen gas again. Then it is produced O3 that we call as O3. It is given O, right? It should be O3. It is O3. This is O3. Ozone. This is ozone. 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 Okay, understand again what happened by UV radiation in upper atmosphere, oxygen gas O2 break down into oxygen molecule, oxygen plus oxygen. Then oxygen molecule react with again oxygen gas. Oxygen gas available in atmosphere. Then 20% of oxygen, this oxygen gas and atomic oxygen react. Then it is produced ozone gas. This O3. O3 is the ozone gas. Then this is the ozone producing by oxygen. It is important UV rays. That is the ozone layer is produced. Ozone layer is produced by this process. Oxygen convert into molecule oxygen. Then this molecule oxygen react with oxygen gas. It is produced O3 that we call as ozone gas. This ozone gas layers present in our upper atmosphere that is important for protect UV rays that you already know. How it is protecting UV rays? You can understand these UV rays absorbed by oxygen molecule. Then it is break down and produce ozone gas. This ozone oxygen relationship is very important. That actually ozone gas not doing more. Ozone gas is not doing more function. It is this oxygen ozone relationship is important. See, oxygen, this UV rays absorbed by oxygen, then produce ozone gas. When this ozone gas ozone is very unstable and breaks into atomic oxygen again. See, ozone gas O3 again convert into O2 and oxygen. This is a cycle. This is a cycle. See, by UV radiation, oxygen gas convert into oxygen plus oxygen. This one oxygen react with again O2. It is producing ozone. Ozone producing. Then this one also producing ozone. O2 react with ozone. It is produce ozone. Produce ozone. It's produce ozone. Now you can't see it. It's again produce ozone. Then this ozone, it is highly unstable, not like oxygen. Therefore, it is again break down into oxygen gas and oxygen molecule. This oxygen molecule again produce ozone. This oxygen molecule again react with this type, then again convert into ozone. Okay, this is a cycle. Oxygen ozone cycle. Oxygen ozone cycle is very important for protect our earth from UV radiation. Understood? Not only ozone gas, this oxygen ozone cycle is the very important point. Ozone ozone is not freely produced. Ozone, to produce ozone, oxygen is requirement. Oxygen ozone balance maintaining is very important. I think you have some idea. CFC gas, some harmful gas, damage to our ozone layer that you already know. Okay, what happened in damage? You can discuss in the future parts. With the equations you can discuss. What they doing? They damage to this oxygen ozone balance. They damage to this oxygen ozone balance. Then ozone producing and oxygen producing balance. The cycle is breakdown. The cycle breakdown, it is damaged to the thickness of ozone layer is decreasing. Then it is effect to our earth from ozone layer. Understood? I got the ozone oxygen balance. Good. Okay, send if you understood. Yeah, I got. Sandeep. Yes, it is the ozone layer. Ozone layer means oxygen convert into ozone convert into oxygen. That's a balance in upper atmosphere. Then always some considerable thickness ozone layer is present in our upper atmosphere. But due to human activities, some CFC gas releasing, some harmful gas releasing, what they're doing, it is break down this relationship, break down this cycle. When they break down this cycle, that means these gases go to upper atmosphere and it is react with this oxygen. I told oxygen is highly reactive. Oxygen highly reactive, they react with these gases. Then what happened? This balance is breakdown, the cycle is breakdown. When the cycle is breakdown, the ozone thickness is gradually decreasing. Then ozone thickness gradually decreasing, what happened? The UV rays, there is no free oxygen molecules in atmosphere to react with those UV rays. Then UV radiation come to directly above Earth. That's why then it is our eye, it is damage to our eyes, our skins. It is lot of damage to animals and plants for entire Earth by these UV radiations. Okay, that's a simple story. Okay, I have given this the rate of ozone production and depletion are equal. Yes, that equal is very important. The rate of ozone production and depletion, that we know. Oxygen convert into ozone, ozone convert into oxygen, the depletion. Okay, if it is equal, the cycle is stable, cycle is normal. There is a constant amount of ozone in the atmosphere, then we can maintain constant amount of ozone. I got when the cycle is normal, always the thickness of the ozone layer is same. But the operating the oxygen ozone cycle requires high UV radiations. These rays coming from sun are absorbed by oxygen. The avoid UV rays reaching the lower atmosphere. Yes, that's a function of this oxygen ozone cycle. Therefore, the health problem caused by exposed to organisms high energy ultraviolet, yes, it is highly damaged. Skin cancers, genetic mutations. Mutation mean change the genetic structures. Skin cancers, they are the problems. They are the effects. Water cycle also I have given. Okay, if we can discuss today water cycle, then 50% of duty is complete. Then atmosphere, that means hydrosphere, if we can complete, try to complete hydrosphere today, right? Then atmosphere and lithosphere, we can, the small part. Atmosphere is the most important part. Lithosphere is a small part. Okay, now come to page number. Again, we have wastewater treatment plants. Again, we have discussed, we already discussed. I will quickly explain that. Okay, come to page number 10. Come to page number 9. Page number 9, 10, 10, 10. No, 9. 9. Adverse effect on natural cycles. Okay, you can read these things. It is simple things given. Adverse effect on natural cycles. That means human effect. The dynamic balance of natural cycle is crucial to ecological balance. To maintain the balance in the environment, disruption and displacement on this dynamic balance is effect to ecological balance. Adverse in technology are the human process that primarily cause to disruption of displacement of this dynamic equilibrium. Combustion of fossil fuel burns organic compounds that have been dormant in the lithosphere for millions of years adds carbon dioxide to atmosphere. That means adversely release carbon dioxide to atmosphere. It is damage to the cycles. Okay, it is very simple. In the industrial production of ammonia, industrially produce huge amount of ammonia. That is effective nitrogen cycle. That is effective nitrogen cycle. It is obtained from industrial process much greater quantities than from process naturally convert. Yeah, they more than naturally convert. Industrially produce more ammonia. Industrial fixation produce more ammonia. It is effective nitrogen cycle. The end result exceeds excess of relative nitrogenous compounds in the various spheres in the atmosphere. Likewise, industrial compounds such as chlorofluorocarbon, like harmful gas, when released to the atmosphere, it is damage to our ozone layer, as I discussed earlier. It is UV rays feed into our lower atmosphere. It is damage to organisms and plants. Similarly, metal extraction, chemical synthesis industry, transportation, textile industry, and polymer industry have significant impact to environment. These cycles, balance of these cycles. Effect of human activities in hydrosphere. Okay, come to hydrosphere. Okay, now cycles completed. Now from this point, we're going to start discuss one by one human effects for hydrosphere, atmosphere, lithosphere, and finally biosphere. Understood? This is the order of the lesson. Up to now, we discuss the basic cycles, and they are actually up to now we discuss what's the meaning of environment. What's the meaning of environment? Living and non-living things around us, doing relationship among them. Then these relationships are there. They are the relationship cycles. They are relate with cycles. If you got carbon, oxygen, nitrogen, water, everything is relationship with other spheres. It is a cyclic manner. Okay, now we going to discuss one by one what are the human human activities for each sphere. First, we starting from hydrosphere. I got the order of the path of the lesson. Okay, the basic part completed. Today, our target is complete the hydrosphere. Hydrosphere is very simple. Okay, if we can complete part of atmosphere, 6 to 65% of lesson we can complete today. Effect of human activities on hydrosphere. About 70% of Earth's surface is covered by water. That you already know. 70% of water. 70% of Earth, it is covered with water. Only less than 30% is land area, lithosphere, land area. Component of the hydrosphere where water exists in all parts. Water existing oceans, natural ponds, everything. Rivers, they are the hydrosphere. Ocean I have given. Ocean, salt water, surface water, water streams, rivers, lakes, dams, simple. Groundwater, water inside the earth, groundwater. Atmospheric water, that means water vapor and precipitation, raining water. Water from polar regions, that means glaciers. Biological water in our living things. Normally, if you got any living things, more than 50%, it is every living things, it is contain water, even in our body. Every parts, the main component is water. Okay, therefore, everywhere you can see available water, more than 70% in the earth covered with water, including gaseous layers in North Pole and South Pole. Okay, it is given the water cycle here. Water cycle I already explained. No need to explain again, right? Water cycle, it is the same thing is given. Plant absorb from groundwater, then it is transpiration, then the precipitation mean raining. Precipitation mean raining. Then after precipitation, it is runoff. Runoff mean go along the land. Then condensation and cloud formation, that we then cloud for transportation and condensation, again given evaporation. This is evaporation from water bodies. From plants, it is transportation, evaporation. Okay, that's it. And it is come to groundwater. It is called as percolation. Percolation. It is given percolation. I got percolation. Yes, everything given. Okay, any doubt in hydrocycle, that in water cycle? Clear, right? Yes. Okay, atmospheric water is converted into surface water by rain. That means precipitation. Rain. Which then the percolates into the ground to become groundwater. Percolate. Percolate means percolation. Percolate into the ground. That we already discussed. Rainwater flow through the rivers and streams and become seawater. Then seawater again evaporate and condense and cloud formation. Okay, come to page number 11. Okay, that you already know, water is a very good solvent. Water is a very good solvent. Therefore, harmful things, harmful substance easily dissolve in the soil, easily dissolve in the water. If you got when the precipitate, that means raining, some harmful gases in the atmosphere. What happened when they go through the atmosphere, some harmful gases and everything, dust particles in the atmosphere, gas particles dissolved in this uh, precipitate water, precipitating water. Therefore, the level of contamination vary depend how the water is used. The amount of contaminants in drinking water should be very low. That is, you already know. For drinking water, it is need to maintain it very low. While the amount of contaminants in use for agriculture may be higher. For agriculture, don't need drinking water like clear water. For agriculture, we use normal surface water. As water passes through the atmosphere, becomes polluted, that I explained. Become polluted by dissolving different gases, as I given here, carbon dioxide dissolving. Remember, in acid rain, it's very important. Carbon dioxide dissolved in water, it is produced carbonic acid. Carbonic acid. Carbon dioxide plus water, it is produced H2CO3, carbonic acid. Sulfur dioxide dissolved in water, it is produced H2CO, sorry, C, H2SO4, sulfuric acid. SO3 also same. SO3 also sulfuric acid. NO2 dissolved in water, it is produced HNO3 acid, nitric acid. HNO3 acid. SO3 also same. Okay, sorry. Okay, what I told you, the water is okay. Yes, the water is present everywhere in the earth. More than 70% of earth covered by water. The water is a good solvent. Therefore, a lot of pollutant compounds and pollutant, non-pollutant, every compounds are dissolved in this water. Therefore, sometimes when they precipitate raining, some harmful pollutant gases can be dissolved in this water. When they dissolve carbon dioxide, it is produced carbonic acid. When they produce SO3, SO2 gases, it is produced sulfuric H2SO4 acid. When it is dissolving NO2, nitrogen dioxide with water, it is produced HNO3 nitric acids. Okay. Come to water standards. Okay, different water standards are used to determine whether the water is suitable for whatever function, whatever purpose. That means think drinking water, what are the required water standards? For agriculture, what are the standards? For whatever industrial usage, what are the standards? What are the quality we need to maintain for this water? Okay, they are the water standards. These water standards vary depend on the application. That for drinking water standard vary from the industrial application. Industrial application requirement vary from the agriculture requirement, like this. There are three main type of water quality criteria standards. The first one is physical criteria, that is always asking exam MCQ questions. Physical criteria. Taste is the physical. Color. Normally taste is not physical. Taste is not practically. We only for drinking water we measure taste, color, turbidity, conductivity, pH value, and total dissolved solid. Dissolved solid amount is it is taste, color, turbidity is correct. This conductivity, okay, but the pH value sometimes we call pH value is chemical parameters also. pH value we consider it is chemical also, but it is given in your syllabus. It is given it's a physical parameter. Taste, color, turbidity, conductivity. Conductivity means ion concentration. Conductivity, the electric conducting ability through water. Then the pH value and total dissolved solid. Total dissolved solid, it is 2 times total dissolved solid and total suspended solid. That we call as TDS and note down this TDS and TSS. Total suspended solid and total dissolved solid. TDS and TSS. Chemical criteria, biological oxygen demand. COD means chemical oxygen demand. If you don't know, please note down. BOD, that's the first chemical parameter. Biological oxygen demand. COD, chemical oxygen demand. Heavy metal level. Different heavy metal. Arsenic, phosphorus, lead, like mercury, like heavy metal. And hardness. Hardness means magnesium and hardness. Is it given? It is given. Hardness. Magnesium and calcium ions amount. That we call as hardness. Again, I have given Acidity. Acidity means pH value. It is same. No? Acidity means pH value. The pH value, physical and chemical both correct. Okay, it is acidity also chemical criteria. Biological criteria, coliform amount, biological organism, harmful organism count, E. coli count, and salmonella count. Salmonella count. Okay. Okay, now 10 break and continue next part, right? Okay, now 10:45. Uh, take a break. And today I hope to discuss up to atmosphere. Up to we can get up to 1 p.m. We can discuss. We can get for 2 hours. Today, if we can complete this lesson, is very simple. Up to 22 page. Up to lithosphere. If we can complete this hydrosphere and atmosphere, then it is perfect. Then within small part, we can complete next part. Okay, then take a break and come at 11:15. I'm starting on time. On time. 11:15. Not 50, 15. Okay, can you hear me? Can you hear me? Mithun? Okay. What we discussed up to now, we discussed the water standard. Water standards. I told water standards mean according to the application, the standards is changing. Standards are changing. Like if you got drinking water standards are very critical. It is very the pollutant level is very low. But if you got agriculture water is different standards. Normal treated wastewater for natural environment, it is different standards. If you got industrial water, it is different standard. This physical chemical criteria changing according to the water application. Okay, I told physical criteria, chemical criteria, biological criteria. We already discussed biological criteria mean coliform count, that means harmful pathogen microorganism amount. Pathogen microorganism amount is a biological criteria. Coliform amount, salmonella amount, and E. coli amount. They are the common harmful pathogens in water. They are the critical microorganism in water: coliform, salmonella, and E. coli. Remember, coliform, salmonella, and E. coli. Coliform, salmonella, and E. coli. If you got drinking water, remember, in drinking water, this E. coli, this coliform and salmonella should be zero in drinking water. Salmonella is very critical in drinking water. At least 1% salmonella percentage, it is very toxic. We can't use as salmonella. At least 0.1, it is toxic. Salmonella is critical in drinking water. Therefore, according to the application, The water standards are changed. The water standards are changed. Okay. I told physical criteria as BOD, biological oxygen demand, COD, chemical oxygen demand, heavy metal like lead type, lead, arsenic, like heavy metals, hardness, and acidity, that means pH level, low pH of water. Okay. Next, I have given the biological oxygen demand mean. The BOD, biological oxygen demand. The biological oxygen demand mean the amount of dissolved oxygen requirement. The amount of oxygen requirement by aerobic microorganism to digest organic matter containing specific volume of water during a period of time. Okay, understand very simple meaning. Think we have water beaker. Think we have water beaker. 1 liter water beaker. It is a 1 liter water beaker. Think it has 1 liter water 1 liter. Then if it is dissolved, these organic matters in this water dissolved by microorganism like aerobic microorganism, the amount of oxygen requirement. Aerobic microorganism mean you already know. Aerobic microorganism mean, think this is the water beaker. When we go with this aerobic microorganism, what happened to the water amount in water? Sorry, oxygen amount is water. The oxygen amount of water is decreasing because aerobic microorganism doing respiration. Respiration process, they absorb oxygen and release carbon dioxide. Then the oxygen level is decreasing. Gradually decrease. That's mean the DO level, dissolved oxygen level is gradually decreasing. When decrease the oxygen level, what happened to the oxygen demand? The oxygen demand, oxygen requirement is increasing. Oxygen demand is increasing. Oxygen demand is increasing. Demand increasing. Okay, this demand or requirement we called as the biological oxygen demand. Then how we can define this? The amount of oxygen demand, the amount of oxygen requirement to dissolve organic substance, to dissolve organic matters in unit volume of water by using aerobic microorganism. Using aerobic microorganism. This aerobic microorganism use oxygen in water, then the oxygen amount, dissolved oxygen level, DO level is decreasing. Due to that, the BOD level, normally the BOD level is increasing when this aerobic bacteria is working on water by dissolving, by decomposed organic material. In this decomposition process, the requirement oxygen, the required oxygen amount we called as biological oxygen demand. I got. Now, can you define the biological oxygen demand? The biological oxygen demand means the oxygen requirement to dissolve organic matter in a unit volume by aerobic microorganism, that we called as a biological oxygen demand. Mitu, understood? The amount of oxygen requirement to dissolve, to decompose organic matter in a unit volume of water using aerobic microorganism. Only aerobic. Okay? Only aerobic microorganism. I got the definition. Others? Shehan? The amount of oxygen requirement to decompose organic substance in a unit volume of water by using aerobic microorganism. By using aerobic microorganism, the definition clearly given in the table. Okay, remember this definition. Don't keep to do later. Complete now. The biological oxygen demand means the amount of oxygen requirement to decompose organic substance in unit volume of water by using aerobic microorganism. using aerobic microorganism. Digest and decomposition. Shena, understood? Okay, COD. Okay, BOD is completed. BOD means the amount of oxygen required to decompose organic substance in a unit volume of water by using aerobic microorganism. Okay, please remember this definition. So always in chemistry part, asking this definition in past papers, you can refer. Always asking these definitions. In your word, this meaning should have, these keywords should have the oxygen demand, the amount of oxygen requirement, that's a demand, the amount of oxygen requirement to decompose organic substance in a unit volume of water by using aerobic microorganism. Okay, same definition you can change into chemical oxygen demand, COD. The chemical oxygen demand means the amount of oxygen required to chemically break down the oxidable matter, that means organic matter, present in given volume of water. Same definition you can change into COD. COD means think we have 1 liter of water, the amount of organic substance, organic matter in this water volume, 1 liter volume, the amount of oxygen requirement, oxygen demand requirement to decompose this organic substance, organic matters by chemicals. Normally we use this for hydrogen peroxide, remember, hydrogen peroxide, H2O2 chemical, by decompose by chemical decompose oxygen requirement per unit volume, that we called as chemical oxygen demand. I got the difference? H2O2, hydrogen peroxide, that we use for this digestion breakdown process. These definitions are very important. Very simple. What is the biological oxygen demand? The amount of oxygen requirement to decompose organic substance in a unit volume of water by aerobic microorganism, aerobic bacteria. What is the chemical oxygen demand? The amount of oxygen requirement to decompose organic substance by using chemicals of unit volume of water. Understood? Midhu, I got the difference? Very simple. Okay, come to third one. The hardness. The hardness of water. The hardness means the amount of magnesium and calcium concentration. The amount of magnesium and calcium ion concentration we called as the hardness of water. This hardness mainly two types. Hardness mainly two types. Hardness mainly two types. This is temporary hardness and permanent hardness. Permanent hardness and temporary hardness. Temporary hardness and permanent hardness. Okay, come to temporary hardness. It can be removed by boiling. That's the main feature. The temporary hardness, it can temper. It is easily, we can remove only boiling. If we heat up to boiling water, then we can remove this hardness. Permanent hardness is not removed by, permanent hardness we cannot remove by boiling. And exchange calcium must be used to removing permanent hardness. We have to exchange, we have to remove ions by filtering or RO, reverse osmosis like techniques we have to use for remove this permanent hardness. Temporary hardness that we can remove by boiling water. Water boiling. there are standards for water use as well as disposal. Yes, in wastewater treatment, when we dispose some amount of water, this standard is very important. If we treat it, then we satisfied as a treatment plant. If we satisfied, we cannot release this water, treated water into environment. It is prohibited because Central Environment Authority for all in for all industries we have to get license from Central Environment Authority. This license we called as environment. This license we called as EPL. EPA means EPL, Environment Protection License. EPL. Every industry need to get this from this Central Environment Authority, CEO, CE, Central Environment Authority. We have to get this IPL, EPL, Industrial Protective License. This Industrial Protective License cancel if we release without untreated or without standards. If we release water without standard water, then the EPL will be cancelled. Therefore, we need to always, when we release treated water into environment, natural sources, the standard maintaining is very, very important. Okay, read this. There are standard of for water used as well in the disposal. If the pollution level of water is higher than value of determined by relevant standards, the relevant waste should be treated and disposed of after water complies with described standards. If it is after treated, very simple thing, after treated, if it is the pollutant level greater than standard, then we have to again treat this water until it's come to Central Environment Authority given standards. Okay, now we are going to discuss water pollution. Water pollution. Okay, read this part. Give me seconds. Read this part in the tube. Very simple part. Okay, so water pollution. Now, what we discussed, what I told, the water is covered. 70% of Earth is covered by water, and different water sources we discussed. Again, refresh. Again, go through the lesson. What we discussed. We discussing mainly the hydrosphere. Okay, hydrosphere. Then in hydrosphere we discuss the water cycle. What are the parts of water cycle? And I told water is a good solvent. Therefore, a lot of pollutants always easily dissolve in this water. Therefore, easily water is polluted. Water is easily polluted. Then I told when we use water to whatever purpose, the water standards very important. We need to maintain according to the application. The water standards need to maintain physical, chemical, and biological criteria. Okay, this is the summary. Okay, now we come to water pollution. Water pollution is the addition of pollution to water. That very simple. I told water is a good. The water is a good solvent. The water is a good solvent. Therefore, easily pollutants and other particles easily dissolve in this water. Dissolve in this water. The level of contamination can vary depend on how the water is used. Yes, how the water is used according to water application, water usage, the amount of contamination is depend. If it is industrial use water, it is the contamination is very high, more than agriculture use water and normal household use water. As an example, drinking water should have very low level of contaminants, while water used for agriculture may higher amount of pollutants. Okay, possible forms of water pollution. Aggregation of small particles. That means the turbidity of water increases. Turbidity means the amount of suspended and dissolved solid amount. That we call as turbidity. That we call TSS and TDS. Total suspended solid and total dissolved solid. TDS and TSS. That's why the turbidity is coming. Turbidity. The aggregation of dissolved salts in water increase the conductivity. When the salt, mineral concentration, magnesium, calcium concentration increasing, then the hardness also increasing. The addition of heavy metals, ions in toxic organic compound, chlorination and disinfections. Is it possible to increase the ion concentration, heavy metal concentration, aggregation of dissolved salt, calcium, magnesium, then it is hardness. It is not given, it is hardness, not down. Increase hardness. Accumulation of harmful bacteria, E. coli, salmonella, cholera bacteria, E. coli, salmonella mainly. E. coli, salmonella, cholera bacteria. When they accumulate with the water is polluted, biologically polluted. Addition of non-toxic substances like sugar, starch, fatty acid, animal, plant waste. Then the water BOD value. The BOD, COD value is increasing. Why? When it is non-toxic substance adding to water, then the water organic matter amount is increasing. When the organic matter amount is increasing, the amount of oxygen demand, biologically and chemically oxygen demand is increasing. Therefore, when they are the water pollution method. Conservation of water from industrial process, oil, grease, heavy metal including in water. Yes, industrial process. Normally, more than household usage and agriculture, the industrial applications are the commonly more polluted in water in industrial applications. Okay, again we have discussed water treatment, that we already discussed water treatment. I got up to now very simple thing we discussed. In hydrosphere I got Clear up to now? Mitu? Amavi? Shehan? Up to now, okay? No any advanced part here, very simple. Only reading this note, you can get the full idea. No any advanced things. Okay, come to water treatment. Water treatment actually we discussed. I'm going to give you a very short introduction about wastewater treatment. Wastewater treatment. The wastewater treatment is a process that treating polluted or unfilled water to human consumption and making suitable for human consumption. Also, industrial wastewater is treated and disposed of accordance with the relevant permanent parameters and disposal standard. Our main target is wastewater mean polluted water. Polluted water in industrial or agriculture or whatever. Polluted water. Wastewater mean polluted water. Our target is this polluted water get within the standards. Get within the standard. That means polluted water get within the standards and release to natural water resource. This treated wastewater we're not going to use for drinking water. It is very difficult to get very difficult to treat up to drinking water. It is very difficult. Therefore, we're not going to treat up to this level. We're going to treat up to certain limit, then release to natural water resource. Then diluted in the natural water resource. Normally, we dispose to river. Then diluted in the river, then the pollutant level is concentration is decreasing. Pollutant concentration is decreasing. There are three main steps in wastewater treatment that you already know: primary treatment, secondary treatment, tertiary treatment. In cell structuralism, I told there is another step. What is this? In cell structuralism, I told 4 steps in wastewater treatment. What is the final one? Primary treatment, secondary treatment, tertiary treatment. What's the final one? What's the final one? Yes, others? What's the final one? Adisha, what's the final one? Primary treatment, secondary treatment, tertiary treatment. In wastewater treatment, what is the final one? In bacteria, microorganism lesson, we already discussed. Yes. Others? Quickly send your answer. What's the final one? Sandeep? What's the final treatment process step? Adisha, not only. No, Sandeep. No. There is another process. No. The preliminary treatment is before primary treatment. Preliminary treatment. Don't mix them. Preliminary treatment. It is. Don't remember this one. This is not given in your syllabus. I given extra things for preliminary treatment. Yes, anaerobic sludge digestion. Anaerobic sludge digestion. Anaerobic sludge digestion is the okay. They are the main 4 steps. If you want, if you can get additional step in as before primary treatment is it preliminary treatment. Preliminary treatment means this is a normally central wastewater treatment plants we use in Sri Lanka, not only Sri Lanka, in industrial zones. The preliminary treatment means equalization process. Equalization means the different concentration water coming from different industry. When it is collect into a single tank, we need to get into single. We need to get into same concentration water. Then this is called as equalization process. The preliminary treatment is the equalization process. Okay, that's not the actual treatment. It is only equalization. We are mixing this water and equalization process. It is not a specific treatment. Not a treatment. Then treatment is starting from primary treatment. Then it is sent to secondary treatment. Finally sent to tertiary treatment. Then released to environment. The collecting sludge in each step we need to manage by anaerobic sludge digestion. Sandeep got anaerobic sludge digestion. They are the main treatment process in wastewater treatment. Sandeep? Okay, now let's come to primary treatment. Primary treatment in the preliminary treatment is equalization process. Arshad, okay? The preliminary is not the final step. Preliminary in before primary. Before primary. That's not the specific treatment. It is a equalization process. Equalization process. Equalization means collecting water from each industry, equalize, mixing, converting to equal the uniform concentration and uniform characteristics. Then it is sent to primary treatment. It is easy for treated. The primary wastewater treatment, primary water treatment, first step, primary treatment. Here water is insoluble part. Insoluble parts in water we can remove by primary treatment that we already discussed. In this water is sent through a filter, screening for remove solid particles. Remove solid particles in water is collected. Large tank allows settling down these solid particles. A coagulation agent. Coagulation agent means we can add polyaluminium chloride. Polyaluminium chloride we can add for this process. Then it is coagulation and proculation. Proculation means this aluminium minus aluminium hydroxide. 3. It is negative charge ion. It is negative charge ion. Then what happened? These positive charge solid particles, positive side solid particles, it is attract to this alumina. That we call as alumina. Okay, then it is attract to this positive charge. Then it produce large solid particles. These large solid particles, when it is in the settling tank, it is easy to precipitate. Coagulation agent is added to accelerate the settling out process. Accelerate. Then when it is coagulate means produce large solid particles. Then easy to coagulate. When it is settling down like this. See, this is simple compound, small particles. When it is coagulation agents, it is produce large solid particles. It is easy to settling down. Precipitate. Understood? This is a primary treatment. This is a primary treatment. Okay, second one, removal of dissolved gas and odor may exist due to the dissolving of gases such as ammonia and sulfur dioxide. That's when anaerobic microorganisms produce these ammonia and sulfur dioxide gases. The water is aerated to remove these gases. Do you remember in last exam paper in 2024 exam paper, the removal of harmful odor gases, they told use reverse osmosis normally. No, you can go to the paper, you can find this question. Remember? 24 paper. Yeah, it is. This. There was a question regarding this wastewater treatment. See, question number 11. Which of the following statement is correct regarding wastewater treatment process? Reverse osmosis is used to remove dissolved gases in bad smell. Then what is the process? The correct statement is aeration. Normally, I told the ammonia, sulfur dioxide like gases with odor, gases with bad smell is produced by anaerobic microorganism. This anaerobic microorganism we can remove by aeration. When it is aerating, the amount of oxygen level in water is increasing. You already know it is toxic environment for anaerobic microorganism. The oxygen is toxic for anaerobic microorganism. Then they can die and the harmful bad smell we can remove. Reverse osmosis also okay, but I told it is a highly expensive method. Therefore, that we not going to use this reverse osmosis for remove bad smells. Understood? Yeah, this is one point. As last time exam. We can aerate this remove harmful gases. For this, by making water cold reservoir step from the top of the bottom. That means that we can spray this water through the atmosphere for aeration through the atmosphere. Then harmful gases in the water are removed. Also, another important point that's also asked in the always in questions. Iron particles like magnesium ion, calcium ion, iron particles, when it is aerated in the previous process, when we spray through the atmosphere, then what happened? They oxidize. They produce oxide and precipitate. Then to remove iron removal, also we can use this gases aeration process. Okay, I think there is a statement. The selected microorganisms used to remove ions and poisonous organic substance. Poisonous organic substance, okay, I told we cannot remove ions by microorganism. How we can remove ions? By air in the aeration, they produce iron oxide and precipitated. Understood? Understood? Adisha? Then you got 1 point to remove gases with bad odor and to remove iron particles. We need what is the treatment process? Aeration. Aeration. How we doing aeration? That we spray through the atmosphere. Spray through the atmosphere. Understood? Simple. Yes. Sandeep, I got. Okay, what's the second point meaning? For this, by making waterfall river, several steps. Waterfall mean it is go through with several steps. You can make spray from top to bottom. Yes. Okay, that is a primary waste water treatment. Okay, come to secondary water treatment. Secondary water treatment. Here, dissolved organic substance. Dissolved organic substance. Primary, what's the main function? Non-dissolved substance. Non-dissolved organic substance. Suspended particles. But in secondary water treatment, what's the function? Dissolved organic compounds present in water are removed by the then we can reduce BOD and COD level. This in this process we use aerobic microorganism, aerobic bacteria to under special conditions. In the growth of bacteria, these organic materials are used as food. These bacteria, this organic substance used as a food and converted into non-dissolved particles, and they produce carbon dioxide. Then the oxygen level is decreasing. Because CO2 is increasing, then the oxygen demand, COD, BOD level is increasing. Oxygen demand is increasing. For that, I told the aeration, artificial aeration is very crucial, important in secondary water treatment. Secondary water treatment, aerobic bacteria do this by exposing the wastewater to the bacteria with high aeration. Okay, they are the main methods: trickling filter method and rotating drum method that we already discussed. Therefore, I'm not going to discuss more. This is rotating drum method. Then we can grow specific microorganism on the rotating drum, and that we can rotate slowly. When they come to atmosphere, it is aerated, and when they go to wastewater, it is bacteria doing their job. It is decomposition process. Decomposition, then dissolved organic compound convert into non-dissolved suspended particles. Okay, this is the rotating drum method. It is a rotating drum. Okay, then this trickling filter method that we already discussed, it is stone or plastic plates we can use for this process. Then the special type of microorganism that we grow on the surface of the stone, and the primary treated water spray onto this trickling filter by sprayers. Then in the spraying process, it is aerated and going to the this particles, these small particles. Then it is going through these particles, going to these stones. It is reacted by microorganism, decomposed by microorganism. Then it is collected here, the treated water collected here, then again pump here. It is a cyclic process. Again pump to sprayers, then again spray into. This is a cyclic process until the dissolved particles convert into non-dissolved particles. We have to circulate this water through this trickling filter. The secondary water treatment is also done with simply by adding the wastewater to a large pond and aerated the pond water, direct aeration by air blowers. We can aerate by, as a fish tank, we can aerate by air blowers. Likewise, when the amount of organic matter in the wastewater is too high, anaerobic bacteria decompose it and reduce the amount of waste. Anaerobic bacteria. It is a special case. It is a special case when the amount of organic matters in wastewater is too high. When it is too high, then if we introduce aerobic bacteria, it is difficult to decompose because the amount of oxygen level is very low. Therefore, we can introduce anaerobic bacteria for this process until they reduce the wastage, until reduce waste amount. Then after that, we can use usual aerobic microorganism process for continue this secondary treatment. Okay, they are a special case. Okay, secondary treatment. Okay, that we already discussed. That's why I quickly discussing. Any doubt, please ask. Secondary treatment, quickly ask if you have any doubt. Everything okay up to now, Adisha? Okay, try to remember everything within this time. Otherwise, it will be very easy for your other subjects works, other lessons works, because this is a final lesson and easy lesson, very easy lesson. Okay. Tertiary water treatment. Tertiary water treatment that you already know. I told the primary treatment. What is the purpose? Remove non-dissolved solid particles. This is a physical process. Primary treatment. The second treatment is a biological process. That's what is the function. What is the purpose of the secondary treatment? Remove dissolved organic substance. Okay, in the secondary treatment, I forgot to tell you. In secondary treatment, by these microorganism activities, by this microorganism decomposition, this dissolved organic substance we can convert into non-dissolved, like suspended particles. Then after that, again we need to send this from this biological treatment to that we need to send into secondary settling tank. Then what happened? Again these particles precipitate and decrease the BOD, COD level of water. Then after that, treated water separate and sent to tertiary treatment. Here, the purpose, it is a chemical process, full chemical process. Tertiary treatment is full chemical process. Primary treatment, physical. Secondary, biological. Tertiary, full chemical process. Then we adding some disinfection agents, disinfection chemicals for this chlorine, ozone, hydrogen peroxide light. They are the common types: chlorine, ozone, hydrogen peroxide, H2O2. They are the common disinfection agent. They are the common disinfection agent that we can use for this chemical treatment. Here, the purpose of rivers remove dissolved salts and the other toxic organic substance from the water. For this, very expensive electroleakage filtration system. Yes, I told in this previous question, the reverse osmosis is a filtering method. Reverse osmosis is RO filtering method that is more expensive. See, it is more expensive method, reverse osmosis, due to high cost. This is used for only drinking water treatment. Remember, wastewater treatment, that is possible to use, but that we not going to use for wastewater treatment. That is only used for drinking water treatment to obtain clean water from seawater. Seawater also we can, after reverse osmosis, seawater also we can use as drinking water because all ions we can remove. That's the meaning of reverse osmosis. Due to the spread of kidney disease in dry regions, dry zone in Sri Lanka, kidney disease. The people in this area have been motivated to use filter waters. Filter waters, because in this dry zone, the agriculture fields is the agriculture area is very high. Therefore, the fertilizer usage for this area is very high. That's the main reason for this kidney disease. Do you know, in Anuradhapura, Polonnaruwa, Mahiyangane, like area, the agriculture, paddy fields, large scale paddy fields. That's the reason. Then the amount of fertilizer, urea, dolomite, like fertilizer usage, chemical fertilizer usage is very high. That's the reason the excess usage of fertilizer, you already know, when we use excess amount of fertilizer, it is go through the precipitate and percolate into groundwater. Then the groundwater hardness is increasing. Magnesium, calcium, the iron concentration is increasing. Then when we use well water, normally, you know, in Anuradhapura dry zone in Sri Lanka, a lot of people use in well water, Lingmatu. Then this well water iron concentration is very high. That is the main reason for kidney disease. You know, if you visit in dry zone, this problem area, at least one patient in one home, one family. It is a worse effect now in this area. The reason is water. Water is the reason. Okay, the reverse osmosis is drinking water tertiary treatment, not for not for wastewater. Then write down other tertiary treatment methods. Other tertiary treatment methods. Write down in the page 15 in the tute. Page 15 in the tute. Write down chlorination. First one. Chlorination. Chlorination. Most popular in Sri Lanka. Commonly used method in Sri Lanka. Second one, ozonation. 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 React with ozone. React with ozone. O3. Third one, react with hydrogen peroxide. This method also highly expensive. H2O2. Hydrogen peroxide. Sorry, H2O2. React with hydrogen peroxide. Okay. Yes, this is RO filter method. Yes, I will show you others. Yeah, this type filtering system. This is a RO filter. Filtering system, not a single system, single filter. It's a filtering system. Reverse osmosis. React with hydrogen peroxide. Fourth one. Microfiltration. They are filtration method. Microfiltration. Microfiltration. Fifth one, nanofiltration. Nanofiltration. Final one, reverse osmosis. That we already know. Reverse osmosis. Reverse osmosis. RO. Reverse osmosis. Okay, they are the possible tertiary treatment methods. Normally in Sri Lanka, use most popular way chlorination. Complete. Okay. Yes. Hydrosphere is completed. Now we're going to move into atmosphere. Okay, I'm tired. Can we complete this part or start next week? The atmosphere is the most important part. Lithosphere, they not asking atmosphere. In atmosphere part, we discussed uh, greenhouse effects, then uh, global warming, ozone depletion, acid rains, most important things, and photochemical effect. Okay, if we discuss this part, the uh, atmosphere is completed. Then we have small part in lithosphere. What to do? Complete today or next week? Mitu? Let's try to complete part of atmosphere. Okay, try to discuss part of atmosphere. Then it is easy for next week. Within next week, we can complete the lesson. effect on human activities on atmosphere. Atmosphere. The hydrosphere is complete. Now it is atmosphere. Atmosphere. The atmosphere is, for easy study again, atmosphere we can divide it into 4 layers. That is the lowest layer up to 15 kilometer that we call as troposphere. Troposphere. 15 to 50 kilometer that we call as stratosphere. Stratosphere. 50 to 85 kilometer, it is mesosphere. Mesosphere. More than 85. More than 85 until 1000, close to 1000, that we call as thermosphere. Normally, thermosphere temperature is, it is very close to sun. Therefore, it is temperature is very high. Okay, what are the main layers of atmosphere? Troposphere, stratosphere, mesosphere, and thermosphere. Troposphere, stratosphere, mesosphere, and thermosphere. Okay, I have given the other layers. And you can understand the ozone layer is where it is located. It is located in stratosphere. The ozone layer in upper sky. And aircraft also, moving in the stratosphere, lower layer of stratosphere. Lower layer of stratosphere. Okay. The separation into layers has been done according to the temperature variation and air density. Temperature variation and air composition change, it is divided into layer by layer. The air density in the troposphere is very high. The air density in troposphere, that means lower layer, it is very high. And the temperature decrease goes up. That means when increase the height of, when increase the elevation, the temperature is decreasing. The temperature is decreasing in the troposphere. In stratosphere, mesosphere, it is different. The air density in the stratosphere is low and temperature decrease. Temperature decreasing. Temperature decreasing as it goes up in the stratosphere. Many global environmental problems have been caused by change the composition of this normal atmosphere. Mean it is mainly troposphere and stratosphere. They are the main effect by human activities. Main coming problems in by human activities. Okay, composition of the atmosphere that you already know. The gases composition of the atmosphere are 2 parts: major gases and other gases. They are the major gas that we already know. Nitrogen 78%, oxygen 21%, argon 0.9%, carbon dioxide 0.04. It is very small amount. The water vapor 1 to 3%. Normally it is less than 1. They are the other gases. They are less than 0.01%. Neon, helium, methane, they are very minor gases. Minor gases. Carbon monoxide, ammonia, particulate matters, dust particles, pollen particles, they are very small concentration in atmosphere. Okay, changes in the composition of the atmosphere due to human activities don't change the main gases constituents. Normally, human activities not change the composition of these main gases. It is not affected, but the change in minor gases. It is the damage. The damage is very critical when we change the composition of minor gases when with human activities. See, as example, carbon dioxide, methane, CFC, they are very minor gases, not like nitrogen, oxygen, not like that. They are very small amount, 0 points, less than 0. Uh, 0, less than 0.01. This might, in human activities, no more effect to major gases. Nitrogen, oxygen, like major gases, no more effect, considerable effect. But it is doing change the composition of these minor gases. These minor gases doing effect to lot of environmental changes. Okay, we can discuss what are the changes. Okay, it is given harmful gases that you can read. Carbon dioxide, how it is increasing, methane, how it is increasing, nitrogen oxide, CFC, chlorofluorocarbon, ozone that we already discussed. Okay, that you can read the table. Okay, now complete this. Please go through this table and get to understand how these minor gases release. Carbon dioxide enter the atmosphere through burning fossil fuels. Okay, now you can read. Please read and complete within this time. Okay, come to next part. The adverse effect caused by the accumulation of various harmful gases in the environment. Okay, various harmful gases accumulation. What are the effect to environment? Okay, the first one is the greenhouse effect. First one is the greenhouse effect. Okay, the first environment effect, greenhouse effect. The greenhouse effect. What's the meaning of this? What's the meaning of the greenhouse? The greenhouse is a completely sealed house. Completely sealed house. It is made with glasses. Made with glasses. Normally in cold countries, cold regions, due to cold period, winter period, they cannot grow plants, they cannot do vegetation due to low temperature. But without any problem, it is totally separate system from the outer environment. Within the glass houses that we call as greenhouses, we can grow without any environment effect. Okay, normally, this is the sunlight. Sunlight come to earth as low frequent electromagnetic waves that you already know. Electromagnetic waves that this high frequent electromagnetic waves, high frequent EM waves. High frequent EM waves come to this greenhouse, inside to greenhouse, and absorbed by land. Absorbed by land. In night time, what happened? They release again into the atmosphere as low frequent EM waves. Low frequent EM waves. Their frequency is low. Therefore, what happened inside the greenhouse? Inside greenhouse, normally in night time, due to plant respiration, the carbon dioxide percentage is very high. In night time, in daytime, oxygen percentage high. In night time, carbon dioxide percentage is very high. Due to this carbon dioxide percentage concentration very high, the carbon dioxide is a special gas that can hold lot of heat amount. Therefore, this low frequent heat particles that absorbed by carbon dioxide, then it is retained in the greenhouse. Then what happened? The entire greenhouse temperature is increased. Entire greenhouse temperature increasing in the night time. Then we can, even in cold climate, we can grow plants inside this greenhouse. Okay, that we call as normal greenhouse effect. Okay, if you want to increase the temperature, then we can, it is fully sealed system. Therefore, we can increase the methane, CH4 gases, and carbon dioxide concentration in this system to increase temperature to keep more heat energy inside the greenhouse. Okay, I got the point. That is we called as greenhouse effect. That's the actual scenario within the greenhouse. Understood? Actual scenario within the greenhouse. The high frequent electromagnetic wave absorbed by land, and in night time, low frequent electromagnetic wave released to the atmosphere. That release low frequent electromagnetic waves absorbed by the special gas types. These gases now we call as greenhouse gases. This is special carbon dioxide, methane like gases we call as greenhouse gases. Greenhouse gases. Understood? I got what happened within the greenhouse. Therefore, even in cold climate, we can grow plants within the greenhouse. Shayan, I good. Do I need to explain again? Yes, I'll explain. Okay, I'll explain. I told. Okay. The greenhouse is a fully covered glass house. You don't you know the greenhouse? This is a greenhouse. I'll show you. Yes, that's a greenhouse. I'll show you clear pictures. Yes, this is a greenhouse. Small scale greenhouse. Wait, I'll show you clear. Yeah, this is a greenhouse. They are greenhouses. See, this is a greenhouse. Yeah, like see, they are greenhouse. It is fully covered with glasses, fully separated from the environment. Normal environment, it is fully separated. Like this one, this is very small scale greenhouse. See, small scale greenhouse. Okay. Normally, carbon dioxide and methane, like special type of gases, they have special ability. Carbon dioxide, CH4, I will explain what are the greenhouse gases. This type gases and water vapor also, H2O vapor, H2O gas, they have special ability to absorb greenhouse gases, absorb heat amount and retain the heat. Absorb karla, retain karaganda polo. Then think in daytime, this is glasses. Through these glasses, high frequent electromagnetic waves, go inside to greenhouse in daytime, then absorbed by these surfaces. These high density electromagnetic waves, this heat is absorbing in daytime. In night time, what happens? These plants release carbon dioxide, then the carbon dioxide concentration is increased. Due to high carbon dioxide concentration, the amount of release in night time, low frequent electromagnetic waves released by surfaces. The surface release again low frequent electromagnetic waves. Then this carbon dioxide like greenhouse gases, the heat absorb and it is a sealed system. In this sealed system, it is retained with this heat. Yeah, they make a LED under the net. That's the thing. Normally, if it is come as high frequent electromagnetic waves, and if it is no any absorbent, it is go outside. No any problem. But due to this carbon dioxide, that they can catch this heat amount and they can retain inside, because carbon dioxide they cannot go out. It is a sealed system. Now they can keep heat amount within this system. Therefore, inside temperature -10 or 0 Celsius, even 0 Celsius, so -10 Celsius, we can maintain at least 30 to 25 Celsius within the greenhouse. Understood? Yeah, the carbon dioxide, methane like gases, they absorb heat amount, then they retain inside the greenhouse. Therefore, the temperature of the greenhouse is increasing more than outer environment. Now, okay, Sandeep? This is special. Carbon dioxide is main. Carbon dioxide, methane, water vapor, they are the main greenhouse gases. They can absorb this heat amount and retain within the greenhouse. They cannot go out. It's a sealed system. Shehan, okay now? Amavi, are you good? Okay. Okay, now this is the effect on this that we called as greenhouse effect in greenhouses. This is the effect. I have clearly given here. This is the greenhouse. These gases retain heat and within the greenhouse. Therefore, the temperature is increasing. Okay, the same thing we can apply for Earth also. Okay, now if we think our Earth, full Earth as a greenhouse, think this is our Earth, understand, Earth, and this is Sun. This is the Sun. Then what happened? High frequent electromagnetic waves, in daytime come to high frequent electromagnetic waves come to Earth, then absorb, and in night time low frequent electromagnetic waves released to the atmosphere. low frequent electromagnetic wave. Okay, now you know our atmosphere, there are some carbon dioxide, methane like minor CH4, water vapor, H2O gas, like minor gases, then they can absorb some part of heat amount. Some part of heat amount they can absorb. Think this is our atmosphere limit. Some part of heat amount, some part of heat amount absorbed by these gases and they retain in atmosphere. Normally, due to this reason, we can maintain the normal temperature 30 to 35 normal temperature. We can maintain the Earth. Normally, if it is no this greenhouse effect, normal temperature is minus 18 Celsius in the Earth. Due to this normal greenhouse effect, and some part of heat energy really go out. Some part of absorbed by gases, part go out. That's a normal process that we call as greenhouse effect on the Earth. Greenhouse effect on Earth, that some part of heat energy absorbed by gases, then they retain in the atmosphere. Remain parties go out from the atmosphere. It is a work as a cycle, energy cycle. Then this energy again come to sun, again come as a circle. Okay, this is a normal greenhouse effect. But the problem is when increase the concentration of these greenhouse gases, carbon dioxide due to human activities, carbon dioxide, methane, water vapor, sulfur dioxide like gases amount increasing. What happened? Huge amount of heat retained within the lower atmosphere. That we called as the global warming. The amount of heat going outside is decreasing. That is decreasing. Lot of heat amount keep within our atmosphere. Then the normal temperature going more than close to 40 Celsius now. Ambient temperature. Then what are the effects when increase the global warming? The glacier, what happened? Glaciers start to melting. Glaciers start to melting. Then sea water level is gradually increasing. Due to this sea water level increasing, lower land layers are covered with what? They are the effects. Understood? That we call as a greenhouse effect of Earth. Okay, you can see here they are the main greenhouse effect. Greenhouse gases, carbon dioxide, water vapor, methane, N2O, nitrous oxide. Remember. Understood? Shehan? Arshad? That we called as global warming. They are the harmful effect. You can wait. Understood? Okay, then we discussed up to global warming. Then 60% of lesson is completed. Then we can discuss next week, remain part and complete the lesson within next week. In atmosphere is the, I got the global warming. Arshad? Amavi? Jehan? Okay, go through again tute. Go through the tute again. We have only 5 pages. Go through again this tute. Today we discussed up to 19th page. We have only 4 to 5 pages. Then next week we can complete remain 40% of the lesson and complete the lesson. And Tomorrow you have ICT practical discussion and ICT practicals, and we have in electricity part we have a small part electricity lesson transformers, no? Transformers and cell structure part animal part. No? Then it is finished. I hope to upload a video for cell structure animal part. I'll upload video, recorded video. Then you can go through it. Transformers and the full revision will again. I will revise the electricity lesson again one more time with questions within 1 day. Yeah, that we can do within next month. Okay, then you can now this week is finished. Now again we meet next week, no, after tomorrow. Then it is final month of your exam. Final months, you have a lot of works. I'll let you know what you need to do, what you need to schedule within final months in next week. And go through this route again. And if there are any difficult point, please send me a photo and ask me in WhatsApp. Okay, that's all for today. Goodbye.